So hi guys, so today I'm going to discuss regarding the thermoelectric and its devices, which is the module 3 in engineering physics. So let us discuss that chapter today. So we can see the syllabus and everything over here, correct? Thermo, EMF, thermocurrent and all. But before that, there is something written here called electrical resistivity and conductivity. So resistivity, correct? I think you all know what is resistivity. The ability to resist the flow of current. Yes, so that is basically the resistivity. R is equal to rho L by A. This already we have studied in our lower class, starting from class 10th and even in class 12th, where rho is called the resistivity, L is length of the conductor, and area, A is the area of the cross section, R is the resistance. Then coming to thermo, EMF and thermocurrent, a very simple concept. So we can see here iron and we can see copper. So we know that iron and copper are not the same, obviously different materials, correct? So what happens is that the iron and copper are heated in a different temperature. Okay, so when two materials which are different from each other, and if they're heated in a what constant temperature, you got the point. And make sure that the temperature in copper is different as well as the temperature in iron is different. Yes, then there will be an EMF formed. What is an EMF? EMF is nothing but maximum voltage. Correct? So what happens is when a temperature at the copper metal as well as iron metal is there, it will form a closed circuit. Okay, and make sure that the junctions of this iron and copper are what maintain a different temperature. So it will form a closed circuit. Once a closed circuit is there, then we get what? An EMF. Correct? And since it's related with temperature, we call it as thermo EMF. The basic meaning of EMF is what? Maximum voltage. And the current flowing through this particular circuit is called thermocurrent. That's all. Simple thing. So basically two different materials heated at two different temperature, correct? Heated at two different temperature. So it will form a closed circuit. So once it form a closed circuit, what happens? There will be an EMF formed. Correct? Since it is related to temperature difference, the EMF is called thermo EMF. And the current flowing through it is called thermocurrent, respectively. That's all. So this is a basic idea and the diagram is very, very important. So we'll go to the Seeback effect and the coefficient and Peltier effect and all later. Let me see the important thing in this. Yeah. So variation of thermoelectric EMF with temperature. So we can see that when a temperature is increasing, correct? When a temperature is increasing, there's what one particular point will get what the maximum EMF. But if I further increase the temperature, then it will drop down to zero, no matter what the temperature is. That is only my variation of thermoelectric EMF with respect to temperature. Okay, and when I get it to zero, then the temperature is called inversion temperature. That also you have to remember. Inversion temperature is the name. And now coming to this, the relationship, correct? So we know SC is equal to UT plus half AT square, right? We have studied Newton's three laws, correct? S is equal to UT plus half AT square. So similarly, we have EMF E is equal to AT plus half BT square, where A and B are arbitrary constants. Okay, and we'll differentiate with respect to what? T. We'll differentiate with respect to T. So why I am teaching you this first rather than the Seeback or the Peltier effect is nothing but this is very, very important for us. Okay, different with respect to T. So d by dt. And A is a constant. What is differentiation of T? 1. What is difference in T square? 2T. So half and 2 will get cancelled. Then I'll get this particular equation. D by dt is equal to A plus BT. That's all. When the temperature, when the EMF E is maximum, correct? T is equal to Tn. So if I get a constant temperature, we all know what differentiation of a constant is what? There is a maximum temperature also, right? Correct. After that, we cannot push it further. Yeah. So that will become a constant temperature. So difference rate constant is what? 0. dE by dt is 0. So instead of dE by dt, what I'll put? 0 is equal to A plus BTN. Then I'll find this Tn. This A will go to this side, it will become minus A, and B will go to denominator, it will become minus A by B. That's all. Okay. Fine. Minus A by B respectively. So at T is equal to Ti, the initial temperature is equal to 0. Therefore, what will happen? In the beginning one equation is there, right? In that equation, 0 is equal to A into Ti plus half B. Nothing. I'm just putting, instead of E, I'm putting 0. That's all. Instead of this E is there in the first equation, I'm just putting 0. Then I will get it in terms of Ti minus 2A by B once I do the rearranging of these things. Okay. So once I'm getting minus 2A by B, what is my Tn? Minus A by B. So instead of minus A by B, I'll put Tn. Correct? So I'll be getting this relation 2Tn. Very, very important. Now I'll go back to the Seeback effect. So the first thing what I told, how the EMF is produced, how the thermo EMF is produced, that same thing only is Seeback effect. In the sense, the production of EMF, correct? At where? At the junctions of two different metals at different temperatures is called Seeback effect. That's all. Okay, the same thing only. That is called the Seeback effect. So here one junction, I told you since it's different temperature, we'll classify one junction as what? Hot junction, and second junction as what? Cold junction. So all of these things in the examination you should write as a key point. So we cannot by heart any of these things, but we can write this as a key point for getting more marks. And we can see here alpha, correct? Alpha is nothing but what? The coefficients, the temperature or the Seeback coefficient I'll see. So alpha is nothing but alpha B minus alpha A respectively. So this is the Seeback coefficient of what? Metal, the iron metal as well as the copper metal respectively. And T1 and T2 are temperature of those two junctions. And where do we observe this Seeback effect? We will observe this in metals and semiconductors. We will not observe this in non-metals. So that also you can write in the examination. And coming to the Peltier effect. So Peltier effect is nothing but the reverse of Seeback effect. Okay, see, it's nothing it's saying. You can see from diagram only. Battery is here, correct? Iron is here, copper is here. Yes, current is flowing through this. So obviously what will happen? Through the iron, it's getting heated, but copper part is here cooled out. So obviously the heat will be absorbed by the cool part of the copper. That's all, common sense. So the same thing you write in the exam. So heat is transferred from where? From the thermocurrent. You have to use the keywords called thermocurrent, thermo EMF and all to get the marks. So heat is transferred through what? The thermo EMF. Okay, thermo EMF. Yeah, so here thermo EMF. Where is the thermocurrent passing through iron? Yeah, from iron it is being passed through the copper. And this part it is heated. Similarly, this part it is cooled. In the sense, the temperature slowly the heat is transferred to the colder region. So this also will become hot. Then once this becomes hot, then the current starts reversing. Okay, so this is nothing but our Peltier effect. And Peltier coefficient. So that is represented by this pi. Correct? Pi is my Peltier coefficient. So heat absorbed per second is pi AB into I. A and B are the two different metals, iron and copper. Heat absorbed. We all know that H is equal to VIT. Correct. H is equal to VIT. Correct. Heating effect. That already we know. Instead of V, I am putting pi AB. What is my IT? Q. Because Q is equal to IT. Q is equal to IT. If I just want to write here, let me see where I can write it. Q is equal to IT. This is one formula. And H is equal to what? VIT. So instead of V, what is there? Pi is there. VIT. That's all. Q is equal to IT. These two formulas we have to know. That's all. So once I substitute this thing, my pi AB, correct? Or the Peltier coefficient is nothing but what? H by Q or H by IT respectively. That's a very simple derivation. So this is the same thing which I told you. A heat absorbed is equal to VIT. So I'll be getting pi is equal to V. Correct. Because I told you what? H is equal to VIT. Correct. I told you what? H is equal to VIT. So pi AB should be equal to V. So Peltier coefficient is numerically equal to the applied potential difference. So that's all, guys. This already I discussed with you. So thank you.